about the normal distribution curve. Normal distribution is when data closely follows a bell-shaped curve. Okay, normal distribution is when data closely follows a bell-shaped curve. So you'll see below the picture, this is a normal distribution curve. And see how it's kind of bell-shaped, like the Liberty Bell? Now, when you collect data, like an old bell. Okay, I'll pull up a picture later of a bell for y'all. Okay, so if you're conducting a survey and you survey enough people and the survey is unbiased, your data will follow a bell-shaped curve. Now, the key is unbiased. Unbiased questions are like, what is your height? What is your weight? What is your shoe size? What is your eye color? Not opinionated questions. Opinionated questions like, do you like school food, are always going to be biased, and their data might not follow a bell-shaped curve. But if you're conducting a survey and it's an unbiased question and you survey enough people, then it will follow a bell-shaped curve. It will be a normal distribution. Now, in this normal distribution, we're going to label it like this. X bar, which is what? Right, goes in the middle. Okay, the mean controls the middle. Then, if you go to the right, if your score is above average, above the mean, you could be one standard deviation above the mean, or you could be even smarter, which is two standard deviations above the mean, or you could be among the smartest, three standard deviations above the mean. Like if these were test scores, if this was data for test scores, these people would be the smartest, like the highest scores. These people would be the average scores. Now, just like we have people above average, we have people that score below average. You might just barely be below average and be one standard deviation below, or you could be even lower, two below, or you could be three below. Get back on. Okay, so the area under the curve is 1 or 100% of the data. So all of your data will be represented under the curve. Remember this little symbol, sigma, represents standard deviation and it controls the spread. And then sometimes they might write it like this, in parenthesis x bar, which is the mean, comma sigma, which is the standard deviation. To work with a normal curve, you're going to place the mean in the middle, which is what we did up there. We put x bar in the middle. And we're going to add 3 standard deviations to the right, which is what we did, plus 1, plus 2, plus 3. I'm just going to abbreviate standard deviations. And then you will subtract 3 standard deviations to the left. Okay, and that's what we did up there. We put the mean in the middle because it controls the middle. We added 3 standard deviations to the right. Those are for the above average data. And we subtracted 3 standard deviations to the left. Once you have that copied, you can go ahead and turn to page 15 and we're going to work some examples. Okay, can I move on? Now are you finished? No. Okay, page 15. On page 15, when I copied these, the curves were pretty light, so you might want to just kind of darken yours up. says work with the normal curve with x bar equals 20 and sigma equals 10. What do those two things tell us? The mean is 20 and the standard deviation is 10. So what do we do first? Put the mean in the middle. So right in the middle of the curve will be 20. Then how do you use the 10, the standard deviation? Correct. On the right side you add 10. So this would be 30, 40, 50. And on the right side you subtract 10. So this would be 10, 0, and negative 10. Okay, number 2, work with the normal curve within parenthesis 10, comma 2 parenthesis. What does that tell you? The mean is 10 because they always list mean first, and the standard deviation is 2. So 10 goes in the middle. And then what would one standard deviation above the mean be? 2 above would be, and 3 standard deviations above mean would be 16. 1 standard deviation below would be 8. 2 below would be, and 3 below would be. So out of these two normal curves, which one has more spread? Right, number 1 definitely does because it's quartile 3 up to, or 3 standard deviations below, not quartile 3, 3 standard deviations below all the way to 3 above is 60 units. Where over here from 3 below to 3 above is only 12. So even though this is taller, the data is closer together in this one. Okay, the data is less varied. Over here it's more varied, more spread out. Okay, now, obviously, we talked about on the first page how when you do a survey, all of your data, so 100% of your data, would be represented in this curve. But it is a bell-shaped curve. It's not a rectangle. Like if it were a rectangle, wouldn't each section be the same percentage and they'd add up to 100? So like if there were 8 sections in a rectangle, wouldn't each section be 12.5% because they'd have to add up to 100? But obviously, this section and this section are going to be the same, but aren't those a lot more than the other sections? So we're going to learn something called the empirical rule. The empirical rule is also called the 68, 95, 99.7 rule. Now the reason for this is you can see in the curve that these first two parts, the biggest parts under the curve, are each 34% of the data. Okay, so the scores that go from 1 standard deviation below to 1 standard deviation above add up to 68% of the data. So 68%, like if this were about a test score, 68% of the kids score within 1 standard deviation below and above. Now 34% of those are above, 34% are 1 standard deviation below. Okay, then the next two sections, up to 2 standard deviations above and 2 below, are 13.5% and 13.5%, okay, because the curve is symmetric. And if you add up 13.5 plus 34 plus 34 plus 13.5, what do you think those 4 sections are going to add up to? 95. Okay, so up to 2 below and 2 above are going to add up to 95% of the data. But then you have people that score 2 above and 2 below. And that's 2.35% of the data on both sides. How'd I get 95? I added up the 4 sections in the middle. And so now when I add up those 6 sections, what do you think they're going to add up to? 99.7. But remember, we talked about how much data is under the curve? 100%. That's why these last 2 sections past 3 standard deviations are 0.15% and 0.15% of the data. And what did those 2 0.15% bring that 99.7 up to 100%? Okay, so the whole curve is 100%. 1 standard deviation above and below together add up to 68%. If you go up to 2 above and 2 below, that all adds up to 95%. And then if you go up to 3 above and 3 below, it adds up to 99.7. That's why the empirical rule is also sometimes called the 68, 95, 99.7 rule. Now, you are going to be expected to memorize these percentages. But don't freak out thinking you won't be able to, because after you work enough of these problems, you'll probably have them memorized by today. Okay? Plus, it's symmetry. As long as you can remember 4 of them, the other 4 are the same, just on the other side. Well, like the first 2 always add up to 68, the middle 4 add up to 95, and the middle 6 add up to 99.7, and then all of it adds up to 100. Okay, so now let's try some examples. The heights of fully grown white oak trees are normally distributed with a mean of 90, okay, and a standard deviation of 3.5 feet. Label the normal curve with the mean and standard deviations and percents. Okay, so what do I put first and where? Right, your mean is 90 and it goes in the middle. Then how do I get these numbers? Correct. On the right, we'll be adding the standard deviation, which is 3.5. So 1 standard deviation above would be 93.5. 2 above would be, and 3 above would be 100.5. 1 standard deviation below would be 86.5. 2 below would be, and 3 below would be, right. Okay, so we labeled it with the mean and the standard deviations, but now they also want you to label it with the percentages. What percentage is this section? 34. So that means this one's also 34 because those 2 add up to 68. What percent is this one? 13.5. And so this one is 13.5, and those 4 together add up to 95. And then this section is 2.35. So is this one, and those 6 sections together add up to 99.7, leaving 0.30 left over, which means this one's 0.15% and this one's 0.15%. So we've done A. We labeled the curve with the mean, the standard deviation, and the percents. Now that we have that, we can answer questions about it. What percent of white oak trees, which is what all this data is about, have heights between 86.5 and 93.5? So from this line to this line, what percent fall in that category? 68%. What percent of white oak trees have heights greater than 90 feet? Right, because 90 feet is the middle, right? So the right side would be 50% of the data. What percent of white oak trees have heights between 83 and 97? 95, because wouldn't that be the 4 middle sections? From 83 to 97 would be all 4 of those, and those 4 add up to 95. And if you measure 100 of these white oak trees, how many of those 100 will be taller than 93.5 feet? Okay, well look, taller than 93.5 will be from this line and up. So what percentage does that add up to? 16%. But of 100 trees, how many trees is that? 16 trees. Okay, they didn't want to know the percentage. They wanted to know how many of the 100 would be taller, and 16% of 100 is 16 trees. Okay, page 17. Class average scores for the first semester of a math class were as follows: 90, 82, 85, 82, 91, 87, and 90. Find the mean, the standard deviation for the given data, round it to the tenths place, that means 1 number after the decimal point, and then label the curve and answer these questions. I'm going to let you try this by yourself before I just do it for you. So take a few. Okay, the first thing you would have had to have done for this question was calculated the mean and the standard deviation. Now, there aren't that many scores, so you could have done the mean quickly just by adding them up and dividing, but the standard deviation requires the calculator for y'all, so you might as well put them all in and calculate it both. What did you get for the mean? Okay, we'll just round it, remember, to the tenth, so just 0.7. What's the standard deviation? 3.5. So the mean controls the middle, so that 86.7 goes in the middle. Then we add 3.5, so this would be 90.2. And then you add 3.5 again, so this would be, and you add 3.5 again, and you get Okay, on the left, you subtract standard deviation. So 1 standard deviation below the mean would be A. 2 below would be A. And 3 below would be A. Okay, so now and then we need to label the percentages. What percentage are these two? 34 and 34. Because remember, the rule is the empirical rule, also called 68, 95, 99.7. The first two add up to 68. The 4 add up to 95, so that would make each of these what? 13.5. And then the 6 middle add up to 99.7, making each of these what? And then you know that how much data is under the curve? 100%, so leaving 0.15% for each of these. Now that you have everything labeled, you can answer these questions. What percent of students scored in the 83.2 to 90.2 range? 68%. Because 83.2 is 1 standard deviation below, 90.2 is 1 above, so those two add up to 68. What percent of students scored in the 76.2 to 97.2 range? Right. Those go to 3 below to 3 above, 99.7%. What percent of scores fall below an 86.7? 50%, because 86.7 is the average. So 50% will be below it, 50 will be above it. What percent of students scored in the 90.2 to 93.7 range? 13.5%. Because that's between 2 and, or that's between of students score above a 90.2? 16%. What percent of students scored in the 76.2 to 86.7 range? 49.85. Does everybody know how they got that? You just go from 76.2, which is right here, to 86.7, which is right here, and you're just adding that number, and that number, and it adds up to 49.85. It's basically everything to the left except for 0.15. So 50% minus 0.15 is 49.85. What percent of students scored below a 79.7? 2.5. Hold on. Did you just really count? What percent of students scored below a 90.2? 84%. Okay, because that's below this. Well, that would be 50, and then add that 34 in, 84. What percent of students scored in the 79.7 to 93.7 range? 95%, because that's 2 below and 2 above the mean. And what percent of students scored above a 97.2? 0.15%. Okay, tomorrow when you see me, we will be practicing this more. We're not going to learn anything new. We'll just continue practicing this, and then you won't see me Thursday. Friday we'll have a quiz.